Hello mathematicians, welcome to Maths with Matt. Today we're going to be looking at binomial expansions using the n-choose R button on your calculator or by working out coefficients using factorials. Okay, so let me introduce this new term NCR. Stands for n-choose R, and it's the number of ways one could choose R items from n items. You may see it written in your textbooks as NR in column format. It's best to think of this as a coefficient picker from Pascal's triangle. So NCR picks us the n plus 1 row and the R plus 1 entry from Pascal's triangle. For example, if we had a plus b to the power of 5 and we were considering the third term r is equal to 2 in our binomial expansion, we would have 5 choose 2, which means we would look for the 1, 2, 3, 4, 5, 6th row and the r plus 1, which would be the third entry. So 5 choose 2 would return the coefficient 10. It's really easy to be able to input this into your calculator depending on which calculator you have. If you're lucky enough to still have the ClassWiz 991EX, then it's just a case of putting in the number n, shift divide, and then the number for r and pressing equals. You'll have to look at your own calculator to see if you can find the NCR button, but it will be there somewhere. If you haven't got a calculator or you're doing a non-calculator paper, there's another way to be able to calculate NCR, and that's using factorials. So NCR is equal to n factorial over r factorial n minus r factorial. Let's try and calculate 5 choose 3 using the factorial method. That means n is 5 factorial over 3 factorial, and 5 minus 3 is 2 factorial. And remember that factorial means 5 factorial would mean 5 times 4 times 3 times 2 times 1, 3 factorial, 3 times 2 times 1, etc. So here we have 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 factorial, which is 2 times 1. And we immediately see that 3 times 2 times 1 cancels with 3 times 2 times 1, leaving us with 20 over 2, which is also 10. So that's the 6th row, 4th entry of Pascal's triangle. So let's now write down our binomial expansion for a plus b to the power of n. And remember, there are other videos that shows you how to do that. We remember that we start with a to the n plus now our coefficient, which is nc1, a to the n minus 1 b plus nc2, a to the n minus 2 b squared plus nc3, a to the n minus 3 b cubed, and we'll just go up to the cubic term. And we'll try and expand 3 minus 2x to the power of 5. I like to write a list to make sure that my substitution into the binomial expansion is straightforward and I don't make any mistakes. So A is 3, B is minus 2x, and n is 5. Remember that I like to put things in brackets because the power applies to everything within the bracket. Okay, let's substitute and solve in stages. We have a, which is 3 raised to the power of n, which is 5. That's our first term, plus nc1, which is 5c1. A, which is 3, and 5 minus 1 is 4, times b, which is minus 2x. Then we have NC2, which is 5, choose 2, A, which is 3, n minus 2, 5 minus 2 is 3, minus 2x to the power of 2. Plus, then we have 5, choose 3, A, which is 3, raised to the power of 2, minus 2x to the power of 3. 3 to the power of 5, that's 243. Plus, now we'll do our 5, choose 3 on the calculator. 5 shift divide 1 is 5, times 3 to the power of 4 is 81, times minus 2x, plus 5 shift divide 2 will be 10, times 27 minus 2 squared is 4x squared, plus 5 choose 3 is also 10, 3 squared is 9, minus 2 cubed is minus 8x cubed. Now we have 243 plus 5 times 81 times 2 is 810, but there's a minus on the 2, so that makes this minus 810x, plus 10 times 27 times 4 gives us 1080x squared, plus 10 times 9 is 90, times 8 is 720. There's a minus sign on the 8, so that becomes minus 720x cubed. And we have our expansion for 3 minus 2x to the power of 5. If you found this video useful, don't forget to like and subscribe, it means a lot. And head over to www.mathswithmatt.co.uk for a lot of free maths and physics resources without advertisement. See you next time.